Okay, ladies and gentlemen, welcome to your chemistry class. Today we're going to talk a little bit about significant figures, or continue talking about significant figures, but more specifically, we're going to talk a little bit about rounding, and we're going to talk a little bit about adding and subtracting and multiplying and dividing with significant figures. So, one thing that we have to understand is that when we use a calculator, um, to execute a mathematical operations, especially with significant figures, especially with measurements. So I know that there is a general rule of rounding that we're all accustomed to from our math classes, but what makes this more specific is the fact that in this case, we are working with measurements. So the first thing that I want to let you guys know is that whenever we use a calculator to execute any any operation with measurements, be it multiplying, dividing, adding, or subtracting, it's important to understand that the answer that the calculator gives us, so let's just type it out, the answer given to us, or given, not to us, given on a calculator, excuse me, given on a calculator, given on a calculator can be derived results with more digits than are justified. Can be derived results with more digits than are justified. Are justified with more digits than um, than are justified by the measurement. And what this statement means is that when you work with a calculator and you divide two measurements, and we're going to see that in a minute, but when you divide two measurements and you get an answer that is really like much more specific than what you asked for. So if you divide, I don't know, something like 3 point, and again, this is just me making up the numbers right here, 3.24 24. Well, you know what, let's make it 8.24. I think it's better if we do something like 8.24 and you divide that by like, I don't know, 2.92. You'll probably get an answer like, I don't know, and again, I'm just making it up. 4.3617. I'm just trying to explain the concept, so this is probably not the answer. Okay, 3624 or something like that. Okay, again, this is just made up. It's not true. I didn't even do it on a calculator. I just want to explain something. This statement means that sometimes when you work with a calculator and you divide two measurements, and sometimes you'll get an answer that has more digits than either of the two numbers you're dividing by. Like, for example, there's three significant figures here, there's three significant figures here, and you have, like, in that answer you have five significant figures. So obviously there are numbers there that don't need to be part of that answer. And what scientists do, or what people do when they're working with measurements this precise, is they'll usually round off. And what we're going to do now is we're going to talk a little bit about the rules of rounding off. But the rules of rounding off more that are more specific to measurements. Okay. So what happens here? Well, what happens when we get an answer like this? So what we do is, when we get something like this, and I'm going to quote from your book, it says, such an answer has to be rounded off to make its degree of certainty much. So Um, Such an answer, again, I'm quoting from your book, such an answer must be rounded off to make its degree of certainty degree of certainty make its degree of certainty match that in the original measurement. The original measurement. So basically, what it's telling us is that if I get a number, if I divide two measurements that have, again, three significant figures, and again, I can't stretch out enough. I just made that up. I don't even know if that answer is correct. It's probably not. Um, but what that says is that if you divide two numbers, and I chose division randomly, but it could happen with addition as well. If you divide two numbers that have, in this case, three significant figures, and then you get an answer that has like five significant figures, what happens is that these numbers are rounded, or this answer would be rounded off just to make sure that the answer matches the degree of certainty of the measurements. So the first thing we're going to do before we go into any specifics of adding and subtracting or multiplying and dividing significant figures is we're going to talk about the rules of rounding. Now, there's a table on page 46 which is important. And it talks about the rules of rounding. Now, the first two rules are really general. And, we've seen them before. The first rule says that if you have a number where one of the significant digits is greater than 5, then you round up. So, for example, if I have 42.68 grams, because the number that is after the 6, in this case the 8, let's say we had to round that up to three significant digits, because the 8 is greater than 5, then I would round it up. So the first rule states that if a significant digit is greater than 5, you round up, and in that case the answer would then be 42.7 grams. Okay, so again, if if this number, in this case, if we're rounding off to the nearest 10th, and again, that's going to be depending on the problem that you have, but if, let's say I have to round this up to the nearest 10th, I look next to the 6 and there's an 8, what that means is that I am going to round it up. Now, the other second rule, again, is a very common rule, and it says that if the last significant digit is a number less than 5, and if I have like 17.32, 17.32 meters, and the last significant digit is the 2. And if I'm going to round that, because the 2 is the last significant digit and it's less than 5, then that means that I round my answer to 17.3 meters. And the other rules, the rules that we're going to see now, which are rules 3, 4, and 5, are pertaining specifically to when there's a 5. So we know what to do when the last significant digit is a number greater than 5, well, we round up. When the last significant digit is less than 5, we round down. But what do we do when it's 5 specifically? So the rule states, the first of the three rules states that a 5 followed by 5 followed by a non-zero digit is increased by 1. And that means that if I have something like this, for example, 2.7851, 2.8751, 8751, because the 5 is followed by a non-zero digits, in this case the 1. What that means, ladies and gentlemen, is that in this case we increase it by 1. So 2.8751 now turns into 2 point. I'm sorry, I missed the number. It's 2.7. I got these numbers mixed up. Give me a second. Let me fix that. I'm sorry for that, ladies and gentlemen. I read the problem wrong. It's actually 2.78, not 87. So I got them back. I got them mixed up. Let me do that. 2 point 2.78. 2.7851. If the number that precedes or 5 is followed by a non-zero digit, which in this case is 1, because the 5 is followed by a 1. The rule states, let me start from the beginning. The rule states that if 5 is followed by a non-zero digit, it is increased by 1. So if I look at this 2.7851, next to the 5, there's a 1. So that indicates that I would have to increase it by 1. So then my answer would now be 2.79. 2.79. 2.79. Okay. The second rule regarding 5 states, and let me type it down here. The second rule regarding 5 states that 5 not followed by a non-zero digits. So 5 not followed by a non-zero digit. 5 not followed by a non-zero digit or digits are preceded by are preceded by an odd digit and are preceded by an odd digit. Odd digit is increased by 1. Is increased by 1. So what that means is this. If I have a measurement as 4.635, 4.635, okay, so the difference between this number or this measurement and the other one is that if I look at the first one, after the 5, there was a 1. So because the number that followed the 5 was a non-zero digit, according to this rule, I increased it by 1. But if I look at the second one, the 5 is the last digit. There's no non-zero digit afterwards. So what do I do now? When that's the case, I'm going to look at the number that precedes it, or the number that's before it. Because if the number that's before it is odd, which in this case it is because it's a 3, then that means that I increase my measurement by 1. So now 4.635 kilograms turns into 4.64. And we're going to do the last rule of 5. Okay. So again, if 5 is the last digit, the last significant figure, and I look at the number before it and it's an odd number, then that means I am going to increase it by 1. But if I have 5 not followed, not followed by non-zero digits, so if it's not followed by non-zero digits, not followed by by non-zero digits, the preceding significant digit and the preceding significant digit is even, the number stays the same. And let's look at that an example here now. If, for example, I have 78.65 milliliters, 78.65 milliliters. Now, 5 is the last digit, just like it was in this one. But the difference is that here, the number that's before the 5 is an even number. It's a 6. So if the 5 is the last significant digit and the number before it is an even number, that the measurement stays the same. So we simply say 78.6. And those are the rules for rounding, specifically when we're working with scientific measurements. Now, what we're going to see next is how we execute operations with them, adding or subtracting these numbers. Um, let's look at that real quick, okay? Um, and give me 1 second, ladies and gentlemen, while I acclimate myself and retrieve the document. And here we go. So now let's talk about adding and subtracting significant digits. Now, there is a rule for adding and subtracting significant digits, and I'm going to type that rule up. And I'm actually quoting from your book, and this is on page 47 of your book. It says, when adding or subtracting decimals, of course, because significant digits involve decimals, the answer must have the same number of digits to the right to the right of the decimal point, to the right of the decimal point, to the right of the decimal point, as there are in the measurement, as there are in the measurement with, as there are in the measurement, the fewest digits to the right of the decimal. To the right of the decimal. And I know that sounds a little bit confusing. And when we start working with the example real quick in a minute, you'll be able to see what that means. I'm actually moving this over here so I have space to type the rule for multiplication. So when we multiply significant digits, there's another rule that we see. And if we multiply significant digits, the rule says that, and again, I'm quoting from your book, for multiplication or division, or division, the answer can have the answer can have the answer can have no more significant figures, no more significant figures than are in the measurement with the measurement and then there are in the measurement with the fewest number of significant figures. They are with the fewest number of significant figures. With the fewest number of significant figures. And if you read both rules carefully, they pretty much mean the same, that your answer is going to have the same amount of significant figures as the measurement with the least amount of significant figures. But of course, they're worded out differently, and we're going to see some examples in real quick. There's just one last thing I want to mention about working with significant figures. And that's usually when you're working with whole numbers or with numbers, you would round them to the nearest. In some cases, you would round them to the nearest whole number. Um, I'm actually looking for the rule here, so give me 1 second, so that way I can quote directly from your book, and it doesn't sound like I'm making anything up here. Just making sure, because this does vary in some books, so it's always good to keep that in mind. Yeah, okay. So sometimes in when you're working with depending on the type of problem that you have, you can round that to the nearest whole number. So now let's just go into the examples. The examples are actually on page 48 of your textbook, and you have the sample problems. Sample problem E, to be exact. It says, carry out the following calculations, express each answer to the correct number of significant figures. So the first one that we have, which is sample problem EA, says subtract 5.44 meters minus 2.6103 meters as well. 2.6103 meters. Now, if we look at the rules of significant figures for adding and subtracting, the rule basically says that you're going to subtract normally, but your answer is going to have the same amount of significant figures as the measurement with the least amount of significant figures. And then again, I know that can sound confusing, especially when you're not seeing it, but let's say you have that problem. What you would do is you would subtract, and if you subtract 5.44 minus 22.16103, so 5.44 minus 2.6103, you get 2.8297. 2.8297. 2.8297. 8297. Now, if we look at the rules of significant figure, it says that we're supposed to have the same amount of significant figures as the measurement with the least amount of significant figures. So if I look at 5.44, I know I have 1, 2, 3 significant figures. And if I look at 2.6103, I have 1, 2, 3, 4, 5 significant figures. And the 3 and the 5 don't have to do with a problem. That's why I chose to write them in different colors. There's just to emphasize on the number of significant figures that I have. So that means if I have 3 significant figures here and 5 significant figures here, my answer is supposed to have 3 because it's supposed to have the same amount of significant figures as the measurement with the lowest amount of significant figures. So if this measurement has 3 significant figures and this measurement has 5 significant figures, my answer is going to have 3. So I know 2 is part of my answer. I know 8 is part of my answer. However, I have to round off. And if I look at the 8, and I need to leave it at 3 significant figures, I look at the 8 and I look at the number next to the 8, which is a 2. Since 2 is less than 5, I look at I have to leave it rounded off to 3 significant figures, which means that I know I include the 2, I include the 8, but I need to include one more significant figure. And the third digit is the 2, but because next to the 2 I have a 9, that means I have to round, and 9 is greater than 5. That means I round that up to the nearest unit, and that would be 2.83 meters. So it's very important that we take into account that. So we need 3 significant figures, and I have 1, 2, 3 significant figures, but when I look at the 2, I know that it's followed by other numbers. And to make this as accurate as possible, what I do is I need to round. So next to the 2, there's a 9, and that means that 9 is greater than 5, so I round that up to 2.83. Now, the second part of problem E says multiply 2.4 grams over milliliters. Let me go back to my red color. 2.4 grams over milliliters. So I have 2.4 grams over milliliters. Grams over milliliters. multiplied by 15.82 milliliters. 15.82 milliliters. 0.82 milliliters. Okay, that's supposed to be an L, but either way, 15.82 milliliters. And I forgot to write the L here, so give me 1 second. Okay, so I'm just going to multiply normally, but I have to take into account the rules of significant figures and also the rules of rounding. So you can use a calculator, or if you don't have a calculator, you can do it manually. And you're going to multiply 2.4 times 15.82. And when you multiply 2.4 times 18.9 times 15.92, your answer is 15.82, excuse me. 15.82, your answer is 37.968. So you have 37.968. 968. 6 and 8. So first, look at the rules of significant figures. And for multiplication or division, it says that for multiplication or division, the answer can be no more significant than the figures with the measurement with the fewest number of significant figures. Again, it's the same rule as this one. What that means is this. I'm going to count, and this is 2.4. So I'm going to count how many significant figures are, or look at how many significant figures are in 2.4. And if I look at 2.4, I know that there are two significant figures. So let me again change the color. Let me use a different color. 2.4 has two significant figures here. And 15.82 has four significant figures. And according to the rule, what my answer is supposed to have the same amount of significant figures as the measurement with the fewest amount of significant figures. So obviously, if I look at 2.4 and 15.82, I know that my answer is supposed to have two significant figures. But I also have to take into account the rules of rounding. So if I have I need two significant figures, I know for sure that 3 is going to be part of my answer. And I lost my, here we go. So 3 is going to be part of my answer. But in order for me to have two significant figures, that means that I have to it's gonna be a whole number because I only need two significant figures. So the problem is that after the 7, which would technically be my second significant figure, I have 3 more. Now, to make this measurement as accurate as possible, what I do is I see the 7, which has to be the second significant digit, and I look to the number that's next to the 7. If I look at the number that's next to the 7, it's a 9. And according to the rules of rounding, that means that if a number is greater than 5, it's increased by 1. So in this case, my answer would be 38. 38 grams to be more exact, because of course here the milliliters and milliliters cancel out, and that would leave my answer expressed in grams. So it would be 38 grams, ladies and gentlemen. And that's it for this video lesson. Hopefully this was useful and helpful for you guys. And if you have any questions, you know where to find me, and we'll see each other in our next class. So stay safe. Bye.